Okay, my outstanding friends, enzymes and disease. Even a deficiency or malfunction of a single enzyme can lead to severe illness, highlighting the importance of these biological catalysts, which we are going to look into right now. Okay, my friends, if you don't know anybody that has a kid or your kid or somebody that you know that doesn't have autism, you're probably not living on planet Earth. It's so rampant now. In some areas in the world, it's like 1 in 20. The kids have autism. They're growing up and having these neurological issues very, very early in life. And fecal matter transplants, I've been looking into them for years now, because fecal matter creates bacteria, and the bacteria create the enzymes. Enzymes are the only thing in your body. They're the only thing that can create chemistry fast enough to make your body function. And there are 75,000 or so, at least, known enzymes in your body. That means there is got to be probably that same amount of bacteria, because they all create a specific enzyme, which is the most elegant molecule ever created. And it would take sometimes millions of years to do the same amount of chemistry that one single enzyme does in 1 second. Millions of years versus 1 second. You would fall over dead just like that. Within 2 minutes you'd be dead if you didn't have the enzymes. And that is what happens with acute radiation syndrome. When you get popped with radiation, it doesn't kill your cells that are in your body. They're more protected than bacteria. Bacteria are killed in your body. And then shortly thereafter you start throwing up, and within an hour or two you just don't have the enzymes anymore. They're gone. They're all used up. You're not producing anymore by these bacteria. And it only takes an hour. And then all of a sudden you start throwing up, which is a symptom of gastric distress. You have diarrhea, all kinds of issues. Now, as I keep getting deeper and deeper into this transition of enzymes created by bacteria, I'm finding they're finding depression, feelings, and I'm going to get deep into it, because I just had somebody in one of my videos ask, well, what about RA? What about rheumatoid arthritis? So I quickly jumped on fecal microtransplants. We report a case of a patient with refractory RA successfully with FMT, which is a fecal matter transplant. It may have a good therapeutic effect. So I start looking into this, and then they find out that it also causes, when you have RA, you get depression. Now, most people would say, oh, the guy's depressed because he's got RA. Well, maybe not. Maybe he's got RA because he's depressed. And because he's depressed is because of some bacteria is missing. This is a loop-de-loop thing here. We got to look at every little detail, because the only thing that creates any chemistry in your body is created by an enzyme. The half-lives are just incredible. I'm going to show you quickly what they say about how fast enzymes work. Then I'm going to show you that they say bacteria are the factories that produce the enzymes. And the bacteria live in these organs. The organs don't make the enzymes. The organs are the housing and the factories that have the bacteria living in there that create the enzymes. The enzymes come out as ribosomes. I will show you all this stuff. And if we don't pay attention to this, your kids are going to be sick, the world is going to be sick, and we have a hero over in North Ireland right now doing studies, and they're working on this in Northern Ireland. Now, that's not the richest country in the world. But they do know they have a hell of a problem. And it's worse than the United States even. Here in the United States, it's 1 in 34, 1 in 36, somewhere around there, have autism spectrum somewhere. And over there, I think it's like a 1 in 20. It's worse. And it's getting worse and worse and worse. Why is this happening? Can we just do fecal matter, testing and get a database? And then it should be a very, very, very simple thing to find out quickly if this is something that can help. It's very simple, very inexpensive fecal matter swabs. Test them and find out, are people that have this type of spectrum problem, what are they missing? What do they have too much of? These adjustments in bacteria will not kill you necessarily, but they will give you a chronic disease. Crohn's, irritable bowel syndrome, gastrointestinal distress, throwing up, nausea, constipation, perforated colon, all kinds of things. Anal fistulas, problems where your gut doesn't have the ability to deal with the chemistry coming through there. Some of that chemistry is very toxic, but your bacteria comes up and says, okay, I know how to deal with you, and it breaks it into something that your body builds to create muscle and tendon and collagens and eyeballs and earlobes and everything. You're 100% product, 100% of you and me is made by breakdown of raw materials like carrots and potatoes and meat and whatever it is. That's just all of a sudden turn into muscles and eyeballs and eardrums and no. Very, very, very specific, very sophisticated chemistry happens there. And without the enzymes, it does not happen. Now, I know I'm rambling on about this, but this is so important. I want to make a strong case for this. And I want to see Kennedy step up. This is support for exactly what he's saying. Because if a kid has no immunities whatsoever in their body to a live virus, which is the MMR virus injections, they can get extreme disease, and autism is not out of the question whatsoever. This is in support of what he's saying. Now, he doesn't know what he's saying, I don't think, because he doesn't understand the relationship between the enzymes and the bacteria and the kid getting sick from being invaded by a live virus that's supposed to have some pushback in your body. But if you have none, the virus comes over and takes over. They say that they know this, they understand this. I don't understand why they can't put these pieces together. And Kennedy is the only one that I can see this has any hope for this. I have been speaking about this for years, and to a bunch of deadheads, not a single ear to speak into. None, zero. They have an idea, and I'm not going to I start to get upset about this. Let me just calm down, and I'll show you the evidence. All right, before we even start, I want you to understand what an enzyme is. It's a little tiny particle that's created by bacteria. All right, I'm just going to throw this at you, then we're going to get deep into this. This is the University of North Carolina biochemistry, biophysics, and this guy knows what he's talking about. I've been looking into him. He understands. And they have found an enzyme that without this enzyme, the biology that it creates would take 2.3 billion years, and it happens in less than 1 second. It says all the enzymes work hundreds of years faster than it would take to do that same chemistry if it happened all by itself, and it would, but it would take hundreds of years. You die, you just fall over dead instantaneously without the enzymes. So it's saying that this half-life, the half-life of breaking things down, is the time it takes for half the substance to be consumed. 2.3 billion years it would take if the enzymes can make that reaction happen in milliseconds. It takes 2.3 billion years for that to happen, and it would. That's its half-life, but it happens in less than a second with the enzymes. Just think about that. It's a staggering thing. Enzyme essential for both plant and animal life on the planet. Without them, you're done. You fall over dead. Within 2 minutes, you're done. You see this? Without enzymes, the body's critical biochemical reactions would slow down drastically, leading to death within minutes. Within minutes. There are thought to be approximately 75,000 enzymes in the human body. Even one can cause severe illness. They're proteins that act as catalysts, speeding up chemical reactions exponentially. Okay, I just want you to be absolutely certain that I give no medical advice whatsoever. I am a researcher. I look and I research what has been put into the public record. Mostly I use the National Institute of Health and government agencies, the big facilities that are making the big claims that literally are the only ones allowed to be heard because they don't want to confuse everybody. And I can understand that. I present some evidence to support basically what they're saying because they're slowly getting into the fact that this fecal microbiota transplant affects almost everything. And this is about rheumatoid arthritis. And they had it successfully treated with FMT, had a good therapeutic effect on RA. And then they go into all kinds of things about mood and, different types of problems with your digestive system, which means you have different type of problem with your bacteria and your enzymes. Now, I have a plan here how we can address this very, very quickly, very simply, very inexpensively. Let me show you my little quick plan, and then I'm going to show you why I say this is what we should be doing. Okay, let's talk about the MMR vaccine. It is a live virus vaccine. Contains weakened but live virus of measles, mumps, and rubella, all three at the same time. And it's designed to stimulate the immune system without causing a complete, full-blown disease. However, consider this. Okay, this is as simple as it gets. When a child is born, they test the gut bacteria, whatever is in the poop, basically. And they start right away and they get a profile of what's in that poop. What has that kid been exposed to? What kind of bacteria is coming out of the digestive system? That is the indication of their immunities, basically, and their ability to digest. Now, after any medical conditions, any issues whatsoever, before and after, they should be tested their fecal swab. That's it. Because any medical intervention almost always causes some issue with enzymes. We'll talk about that in a second, because it affects bacteria just exactly as measles do. Now, anytime they have a shot, anytime after they have any illness whatsoever, you just simply match the results of this fecal swab to the different database, which we have to make because it doesn't exist that I know of. And then all you'd have to do is send a picture of your poop, I think. Using AI, it would pick up, you'd have to have a special app that would turn all those into spectrums. And every single different type of stuff would have a different color, because it would be the same light hitting it, but you would pick up different colors coming back, which would indicate they were hitting different types of materials. And those different types of materials send off different colors. We can associate those colors to gut bacteria eventually, not right away, but we'll see there's a whole lot of yellow in a guy that's got measles. Just listen to this right now. Well, that's all I'm asking for is a database and microfecal swabs. Measles can affect gut bacteria and the gut microbiome. Measles do that to you. The measles virus can infect the intestinal tract. It's killing the lining of your gut, potentially causing intestinal inflammation. It's attacking your gut and affecting the gut microbiome. It can lead to digestive issues like diarrhea, increasing the risk of secondary infections. Additionally, measles can impair the immune system, including gut-associated immune system, making individuals more vulnerable to gut-related infections. That is basically identical to acute radiation syndrome. Okay, I found this quite interesting. Measles affect the gut bacteria and the gut microbiome, causing intestinal inflammation and, problems with the gut, which is almost all diseases related to the gut, just exactly like Hippocrates said. Now, they're talking about in 2002 the effect of this Pentavac and measles, mumps, rubella. And they're talking about it may cause intestinal inflammation, blah, 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 blah. Now, listen to this. This is 1995. Is measles vaccination a risk factor for inflammatory bowel disease? Measles virus may persist in the intestinal tissue, particularly that affected by Crohn's disease. People who have Crohn's disease already don't have the right bacteria down there. So when you give them the measles, there's nothing to stop it. So it's especially bad for people that have inflammatory bowel disease. Okay, again, this is just research, and the evidence is all over the board. This goes back to 1995. Is it a risk factor for inflammatory bowel disease? People that have Crohn's disease, this can be bad, really bad, and I don't know what they found, so I'm not going to comment. What happens when you don't recover from the measles? The lining of the gut causes loss of proteins, which are these enzymes that carry vitamin A around the body, so you're not digesting the food correctly or having the transporters that carry things. Now here's another one. This is 2007. No evidence of persisting measles virus in intestines, which is juxtaposition to the other one that said there was. Now we go clinical significance of measles, gastrointestinal complications. Everything's about gastrointestinals. Measles probably infects the intestinal tracts of most persons with measles. All right, gastrointestinal complications. With people that get measles, it appears to have gastrointestinal complications to begin with, maybe. Again, all research, just trying to figure this out. And the measles probably infects the intestinal tracts of most persons with measles. Now, here's from Johns Hopkins. What to know about measles and vaccines. Now, this is February 2025. I haven't even seen this one yet. And I did actually go to Johns Hopkins. I took a course on genomics there for the gene sequences of what causes what. And a lot of the gene sequences are correct in people that have problems, but they're not being turned on. There's switches in there. They call them methylation, mostly is what's called, which turns the switch on that allows the gene to do the job that it's to program. The genes are programs. They're just programs. But they have to send out and get all the products and build the protein or the enzyme to do whatever the gene said to do. So first of all, it has to turn it on. Then the gene has to send out its guys or whatever it does. Wow, I am finding so many things that I missed, but they're brand new. Now this is from Johns Hopkins, and what to know about measles and vaccines. This is just last month or a couple months ago. Now here's another one right down here too. This is a year ago. Measles vaccine more likely to be completely ineffective in whatever. It says, we think this means they take longer to catch up in developing their gut microbiome. Everything is about gut microbiome, and this is all, these vaccines are to very, very young kids. Here's autism and bowel inflammation and measles. This is autism back to 2002. It goes on and on and on about these different studies that have been done. And again, I am just research. So these I find very interesting to see what everybody has said, because you're going to find conflicting ones. I don't care what you look into. One of them will say this and one of them will say that. I want to see the evidence. Show me some evidence. Don't just tell me, well, it's not peer reviewed, so it's not, nobody can accept it. No, I want to see the evidence. I don't care about peer review. Peer review means they won't let you speak. Evidence is not allowed anymore in most cases. I want to see evidence. And the evidence I have seen points to these possibility of complications. There's no question about it. Absolutely none in my mind. Okay, this is from my alma mater, I guess they'd call it, Johns Hopkins. I went there for genomics, and they're talking about measles outbreak in the U.S., highlight the importance of vaccination. Okay, what else do they say about vaccination? All right, let's just start with this. Measles can impact gut bacteria by affecting the immune system's ability to recognize and fight off infections. What it does is it kills your good bacteria. Measles virus can wipe out the immune memory. It's not a memory, it's the bacteria that create the immunities. So it can wipe out the immune memory, including memory for beneficial bacteria in the gut. Not memory. The beneficial bacteria is gone. I believe. This is, again, research. I'm trying to find out if they've ever done this, and I can't see any evidence where they've looked to see what it actually does. It says it wipes it out, but they're saying it wipes out the memory of it. No, I believe it wipes out the actual bacteria, because the bacteria create the enzymes instantaneously. So if the bacteria is there, you're going to have the enzymes. The enzymes are what will give you the immunities. This is incredible. Here's another one. Viruses eliminated 11 to 73% of the antibodies that were present before the infection. You wiped out all of your immune stuff. Now, this is Johns Hopkins, and again, I haven't read this, but I did go to Johns Hopkins. I wasn't impressed, to be perfectly honest with you, but let's see what they have to say. And all of these things are, they're talked about exactly what I'm telling you. The gut microbiome complex community of microorganisms live in the digestive tract, play a crucial role in digestion, nutrition, absorption, immune functions, everything. Nothing happens without the enzymes. They're not talking about the enzymes, they're just talking about the microorganisms. Measles can disrupt the balance of the gut microbiome. Measles can disrupt it, potentially leading to changes in the composition and activity of beneficial and harmful bacteria. They kill it off, they take over, they invade, they now own that space. And if you can't get it back, they continue and make you very, very sick and could cause you to die. And that's because they are live viruses, and if you have no way to fight back, measles can impact you very seriously, and all you have to do is be missing one enzyme. Now, these vaccines are very important. The measles vaccines, yes, absolutely 100%. But they don't have to use live virus, I don't think. I think there's another way to do it and use actually dead virus and still get the same effect. You know, I thought they had a vaccine that didn't have to be live. Now, I asked, could you have one that wasn't live? And it says, no, the MMR vaccine does not contain dead virus. They are alive, but they call it attenuated. They're weakened, meaning it contains weakened, but they're still alive. And it's versions of the measles, mumps, and rubella. All those three things are attacking you at the same time. And if you're missing any kind of ability to fight back, you know, it's going to trigger a response. But your body has to trigger its own response back against that invader and say, okay, now I know who you are and I know how to deal with you. We can take a little hit on this. But once you're gone, you ain't coming back. And that's what happens, and then you become immune. However, if you have nothing to stop that invader, you're in trouble. All right, everybody's heard of nuclear radiation. Oh, it's scary. Well, yeah, it is. Now, this is a Geiger counter, and it just tells how much nuclear reactions are going on in this particular area, and it counts them off as microsieverts. Yeah, microsieverts per hour. And there's a certain range that they claim is just normal, and there's elevated ranges. Now, this acute radiation syndrome is the elevated ranges of these little decays, and it's picking them up as like pop, 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 pop. And if you get, then you're in trouble. Just a, not a big deal. So, why is it not a big deal just because you get every hit only a few times here and there versus a lot of them at once? A lot of them at once will kill a lot of bacteria at once in you. It won't kill your particular cells necessarily. Some might get killed and dried out and burnt up and so forth. However, primarily the bacteria in you is going to get smacked. And they will die, and you will get radiation sickness, acute radiation syndrome. And it follows a pulse. It's caused by being exposed to high amounts of ionizing radiation. The ionizing means it rips little particles apart. So you have atoms like this. Ionizing means it comes in and rips a couple of pieces off. Now you got some serious damage. That's what ionizing radiation is. And you just get it just like that, instantaneously. But it hits your body cells. They're strong enough to take that hit, primarily. But bacteria are very fragile, and they just get damaged, and it kills them almost instantly. Now, the symptoms of this damage to your bacteria can start within an hour of being exposed. It can last for months or until you're dead. Early symptoms usually nausea, vomiting, loss of appetite, diarrhea, all of that stuff. Acid reflux, your stomach, you lost all your digestion. You can't digest, and within an hour. That's how quick you can be damaged from this radiation exposure. Now, what is a reasonable dose? We're up here at 0.14 microsieverts. And it's an average of 0.09. This thing here, I think, is giving off some extra activity, but I don't know. Anyway, it bumps up and down. So I'm in a good, consistent area. But what is it supposed to be? Well, let's look up what is good and what's bad, because I'm telling you right now, even a chest X-ray can kill off a lot of your good bacteria, I think. All right, everything is decaying. There's a lot of decay going on. So how many microsieverts per hour is normal? Levels of radiation exposure, how much do people receive? Now, this is the sources where it's coming from, and this is the dose you're getting. All right, so external dose rate from natural background just floating around is from 0.06 to 0.2. I'm at 0.13 or 0.14, averaging it at about 0.09. So I'm in that lower end of the normal zone. Now, see, it jumps up sometimes, it goes up, sometimes it comes down. I think this thing here is giving it a little extra hit. Anyway, the dose rate from natural background total should be 0.3 to 1.5 total from all different sources. However they want to deal with that. Now, when you go up in an airplane, up high, you're getting more radiation, so you would be up to 3 microsieverts. Okay, because you're up there closer to where the radiation is coming in. Now guess what? If you do a 10-second chest X-ray, you get 20,000. All right, 20,000 microsieverts. Well, that's a lot. I would imagine you would damage some bacteria in you. Chest X-ray, and that's where all your blood is, and that's where all your bacteria and your lymph and all that's floating around. You're going to get a good hit in that particular chest area. Wherever it's not being damaged, you're probably going to be okay. But I would say that I would like to see before and after the bacterial count within 24 hours or even 48 hours. But right away, boom, right away, before fecal swab, after the chest X-ray, and then in 24, 48 hours, whatever, half a dozen tests, whatever. This should be almost free. If you had the right kind of software in a cell phone, and you had the right preparation of the poop, and you took a picture of it and sent it to the lab through just, and instantaneously would come back and say you got too much yellow, too little blue, and that means you need some of this acidophilus, and you've seen the returei and all these different species of bacteria or enzymes, whatever. We should be able to do something, but we need a database first. Without the database, you just have no idea what's going on. There's absolutely none. Look at this, way down to 0.3. That's strange. Anyway, and these are all frequently asked questions about the Geiger counter and so forth. It's just nice to have. You can check around and see what's coming and going with the radiation now. And they have to wear badges at CERN and places like that, because they're in where they're smashing these things and they're throwing off big chunks of particles. And when you get it with this, it's not like this. These things here cause damage. This is like just the tiniest little bit of basically dipole electrons, I would think, is what you're clicking here. And they're just being popping off. You know, this just occurred to me. They're saying the complications of measles can occur in anyone, including in healthy children and adults. Even though you're healthy and you get this measles virus, it can wipe out the body's memory of bacteria and viruses. When they say the memory of bacteria and viruses, does it actually wipe out the bacteria and the viruses, kill them? Or are those viruses and bacteria already gone and left behind the tiny little ribosomes and the virus programs? So your body's been programmed, you don't need the bacteria anymore. That's possible. I can't say that's not possible. But you should be able to tell what's in the poop through these fecal swabs and spectroscopy, which looks at every little fluctuation of the wavelength and tells you the different types of molecules that are in that poop. And if you see there's a ton of this type of molecule, it shouldn't be, you maybe got C. diff. Or if there's none of this and you should have enough over here, you maybe have something with your insulin or who knows what. But I want to see what Johns Hopkins has to say, because this is brand new. I was surprised to see this. 2025 just came out. Look, measles can ravage the immune system. There's Georgia Tech. That's another one. This is time to look into this. Nobody would even talk about this. Doctors wouldn't talk about this because they were scared. I don't blame them. Look, you heard it's 2025. They say it can wipe out your body's memory. That's Johns Hopkins. Okay, we might want to consider this. Measles reduces the amount of beneficial gut bacteria. All right, it can lead to a decrease in the population of good gut bacteria. All right, this is the whole idea. We have to replace that. But we first of all have to know what is the good gut bacteria. Here is what we need to do to make this all work out. We have to know right from birth up. Now, I have a new approach to this. Originally, I thought the bacteria was there and it lived there and it never left. All right, but that's not necessarily the case. Some of that bacteria may have been there, created all the enzymes your body will never need for your whole life, and is gone. That I had not considered. What we need to do is get this database at every stage of life and what bacteria are prevalent in these stages of life. That I had not considered. But that's just in addition to this. So we need to get them starting right from birth every year of every kid and see what's normal in that kid's age bracket, where they live, all the different things about them. Now, and then we get these different tests after and before and after every kind of medical intervention, after shots, after illnesses, everything. And we see, is your gut bacteria correct for whoever you are, what age, what sex, all of that stuff. Then, and we need to have the database, and we match it to whatever region, diet, sex, race, whatever you are. Then hopefully we could use spectroscopy, just taking a cell phone, going click, and of a prepped sample of poop, and send it off through the spectroscopy, which is nothing more than wavelengths of light. And they'd receive all these wavelengths of light, and they'd say, whoops, you're way too high on this one and way too low on this, or whatever. And at some point, that database would interpret how to deal with these variances and what you would need to bring it to an optimal level, because one might affect another. This is going to be a huge database. There's 75,000 enzymes in the human body that they know of, basically. So, and then if we could use AI through spectroscopy, we would be golden, I think. So everything that I have talked about, I believe, or will talk about, supports what I'm saying. And if we had a database of the normal bacteria in the certain age group of people, does it change? I don't know. I had always thought once you had that bacteria in you, it would live in you forever, and it would just continue to repopulate itself, which basically it does. That's what I always thought. Some of them maybe come and go. I don't know. That's why we need them in all these different age groups. See, this is what I'd like to see. Is it the bacteria is actually gone, or did it just forget? They're talking about immune amnesia. All right, so the immune system disruption because of measles can impair the body's memory of past infections, which gives you, so you can get infected again of something you should have been immune to. Apparently, that's what they're saying, which is a phenomenon known as immune amnesia. You just forget how to respond to this. Well, maybe you don't have the bacteria to create the enzymes to respond. They were killed off by that measles infection long ago. That's possible. Did they look for that? I don't know. It means the body can lose its ability to quickly recognize and respond to future infections, including those caused by bacteria. So you just didn't see them coming, and all of a sudden they're there, and you can't respond to them, or it takes you a very long time to respond to them. So once again, it's strictly research. Now, this is Johns Hopkins. They're highly respected. And again, I did go there for genomics, which is the programs that are in these enzymes. They're little programs. They do a very, very sophisticated job. And I can show you all this, which I suppose I should, so let's do it. Okay, my friends, these are fully understood little bacteria. They're single-celled. Some of them have flagellas, some of them don't, some of them have spikes, some of them have a little this and that. But they have a program built into them. That program is designed to create a string of polypeptides, I'll show you in a minute, that ball up into what's called a ribosome. That ribosome is an enzyme kit. All right, and it can pop open elegantly to enormous size. But when it's this size here, 1 million of those can fit into one single human cell. 1 million, plus all the other stuff in the cell. So they're just everywhere. Now, they're created by bacteria, and every strain of bacteria creates a different style ribosome. Some bacteria don't create ribosomes, I think. I think some of them are just cleanup guys that are like macrophages going under, eating other things. These are squirters out of little enzymes. Now, this is what they look like, a bacteria, and they float around in a fluid-filled highway, which was never known about before. I would be surprised if your doctor knows about this, and I'd be absolutely stunned if they know about the importance of it. This is, it says, meet your interstitium, a newfound organ. This was published in 2018. That right there, that white layer, is the interstitium. And what does that mean? They call it interstitium. It's a fluid-filled highway. And in that layer is all kinds of fluid, and underneath this dark layer here is where you have your bacteria and your enzymes and so forth collect down in here, and they squirt right into this fluid-filled highway and get delivered through the body. It's basically the lymph system in the fascia area. You have, this is basically fascia under here. This is vital flesh. Fascia is the coating, which is basically a membrane. However, they didn't realize there was this layer above the fascia, attached to the fascia, that was the fluid-filled section where all the fluids in your body can move around very, very quickly. And they squirt out the enzymes and the bacteria from here into that layer, and they go everywhere they have to go. This layer up here is basically expendable. It's skin and it's the outside layer. It rubs off. But this, you don't want to get through there, because now you're down into your vital flesh, and that's where you get damaged and serious. All right, there's a certain layer here that's just a stretchy little gooey layer. You see all these balls? And that way there you can move all the way around like this and that, and you'll come back to where these balls are basically anchored together. See how sort of homogeneous that is? That's so you come back together. Now, that fluid-filled highway is the key to your health. That's your immune system right there. Okay, once again, National Institute of Health. I'm not just taking anybody off the street here. This was from them about fecal matter transplants and autism. The results of these studies that they did was the search identified a total of 5 studies, 2 prospective open label studies, 2 retrospective observational studies, and a case report. However, no randomized controlled trial was identified. Why? Why isn't somebody doing that? All 5 studies reported a significant post-FMT treatment. That means after they got their fecal matter transplant treatment, improvement in neuropsychological assessment of autism spectrum disorder. All 5 studies. However, there's no trials. No randomized trials, no big interest in this, it appears. It's hard for me to understand what is the motivation behind not being motivated to do this. One last time, all I'm saying is we need to start taking fecal swabs and just doing the database. Get somebody that has the spectroscopy ability to come up with a little app for the cell phones to go click, and then some app to send it off to AI, and AI examines the frequencies and says, here's the different concentrations and the different frequencies of light, which would be different molecules, which means would be different atoms, which means would be different, living little organisms. And sooner or later, you'd be able to identify them. And at that point, you could have a database of everything. So we need, and just record it. And then search it. You don't have to have people's names. You want to know what their health conditions are and what was in their bacteria. It's not a big stretch here. Once you could figure out what the different bacteria were, I don't see any reason you shouldn't be able to ferment them, make them yourselves, and not necessarily at home yourself, but make them in factories under very controlled conditions where you had the right bacteria and you tested it before it was shipped or whatever you did with it, and we matched the results of these people's problems that have their fecal matter being tested and see what it is. And sooner or later, we should be able to isolate these strains and enzymes. It appears that virtually any disease that I've looked up at virtually every one of them. And I check, and fecal matter transplant, does it help? Yes. Even with baldness, peanut allergies, everything, just anything. Put in anything you want. Parkinson's, Alzheimer's, everything. 100% right across the board. With fecal matter transplants, it appears to have, in most cases, it says significant improvement. That's all I can tell you. They're the only things that make enzymes. All right, listen to this. People that were getting treated for Clostridium difficile with fecal matter transplant, alopecia erythra, some of whom also had this whatever. These patients experienced resolution of their CDI, Clostridium difficile, and subsequent hair regrowth after FMT. They had one guy, I think he was like 86 years old, and he had the something universalis, which means all of your hair goes from everywhere. And he had the fecal matter transplant, and he got his hair back. Another one had Alzheimer's. He got the fecal matter transplant, and his Alzheimer's went away. I'm telling you, just start looking them up. Look up anything. I don't care what you look up. See, here it is right here. They're using fecal matter transplants to treat peanut butter allergies. For basically for all food allergy. If you're allergic to it, it means you can't deal with it. You're not able to deal with it. Well, what deals with it? Enzymes deal with it. Treatment of peanut allergy and colitis in mice. Success of FMT for treating these things. Fecal transplant pill shows promise. They finally gave up on this fecal matter transplant stuff from this place, Open Biome. I thought I just saw them somewhere here. This guy here, they finally gave up because they made it so hard. Well, hold on a second. Yep, here it is. Open Biome, the first public stool bank, is winding down its stool bank operations while remaining operational to focus on microbiome research. As far as I'm concerned, that research has been done. Now we need to focus on a database and how to supplement and how to accumulate that data and how to make it easily accessible to virtually everybody in the world. All right, they plan to resume shipping existing stool inventory to physicians in May as they begin phasing out the program. I just showed you how important this is. While Open Biome is no longer actively collecting, screening, and shipping stool for fecal microbiota transplants, they will continue to research and develop new treatments in the field of the microbiome. New treatments, what does that mean? Pharmaceuticals, I think. Now, I just showed you how effective these things are and how important this would be to look into. Now, this is the state of fecal transplants. This is our government has made this illegal. Now, listen. This is an update on this microbiome has been permitted to continue distributing. This is back in 2024. So there's, well, this and that, maybe they can do it, maybe they can't. Well, and then they finally, Open Biome just said, forget it. You guys are making this so hard, we can't do this. All right, my friends, I think I know exactly what's going on here. Investigation on new drugs. These INDs are what pharmaceutical developers, these are the big business guys. They use these INDs to act in accordance with federal laws on the distribution or use of new drugs across state lines before they gain market approval. Well, market approval would change things dramatically for pharmaceuticals if they could use fecal matter transplants. So what happened? Why did Open Biome decide to discontinue its fecal matter transplant distribution? I talked to these people a number of times, and I could see they were discouraged when I talked to them. But anyways, that's why. I know why now. After October 31st deadline mentioned above, the FDA will need to issue a decision based on the submission of Open Biome's IND application or other written permission to continue distributing FMT. It's been shown it's pretty safe. Well, very safe. As Open Biome has stated publicly, the discontinuation of FMT distribution is not related to the safety or quality of the products, but rather the difficulties the organization has had in making its IND submission over the past 22 months. They've been fighting back against these people, making them jump through hoops. They can't jump anymore. Finally, just forget about it. We'll just close up. It's also worth noting Open Biome receives FMD products it distributes nationwide from its partner, University of Minnesota, which already has its own IND. So they could have been fine distributing them, but they want them to have their own. If the University of Minnesota has its own IND, why does Open Biome need one? It's just to keep it off the market as far as I'm concerned. That's what I see. I have my own opinion. I can have my own opinion. That's my opinion. It's all about money. Okay, spectroscopy says you can look through all these different colors and they will point you to, in chemistry, their properties and the behavior of matter. It's physical science within the natural sciences that studies the chemical elements. What's the chemistry that make up the matter and compounds made of atoms? You can actually see it because the color that bounces back at you is the spectroscope, and the spectrum indicates the type of material is the light is bouncing into. It's not hard to understand once you understand how light reflects. The same color light you're sending, some of it bounces back in different colors. Why? It's because it's a different material, different molecules. And in the case of poop, it's different bacteria. Okay, my friends, let me wrap this up here. I'm going to tell you right now, very few doctors understand this layer is even here. The ones that do understand it's here, I don't think understand its significance and the membrane activity and the ribosomes and the bacteria that live in that layer to protect you from invasion. It's very, it's actually quite simple, to be perfectly honest with you. Now, I have a whole plethora of things to talk about. How the ribosomes are created inside the bacteria, what they look like when they turn into enzymes. Are enzymes proteins? What do they look like, or what are they structured like? How could we use spectroscopy to look at these things? What's the fluid-filled highway versus the fascia, the mucosa? Where's the skin? Where's the vital flesh? How are these ribosomes transcribed? What do they do? Can they protect you? Parkinson's linked to gut bacteria suggested unexpected simple treatment. These are bacteria and ribosomes. I'm going to get very deep into this because I think I understand this as well as anybody in the world. I literally discovered the fluid-filled highway working with my fossils. I could see this because they're fossilized in its fullness. They never saw it because at the autopsy it was flat as a pancake. So it became the unexpected organ and now is the biggest organ in the human body. Right there. Because it covers everything. It covers everything in your body. Your skin is also considered this. Your organs, your muscles, your bones, your tendons, your liver, your kidneys, your eyeballs, everything has one of these membranes. And every membrane has one of these fluid-filled highways to facilitate that membrane. And if you don't have the fluids in there and the bacteria and the enzymes, you are subject to invasion. And one single enzyme missing can make you susceptible to being invaded. Now, it's unlikely that one, well, it depends on which one it is. If it's something that holds up your tight membranes, junctions, well, then you're in trouble. They get floppy, they get weak, and you can get, and there's all kinds of things happen. There's 75,000 membranes in your body. Just think of that. And every one of them, as far as I know, has to have a bacteria that created it. That's how they're created. Enzymes are created from bacteria. Bacteria are the factory that create enzymes. Just look it up. All right, I love you all. The next video I'm going to do is going to be an extremely deep detail about how we can hopefully do this with a database and then use AI to see the shapes and the colors and what ribosomes and what bacteria are living in that poop. And hopefully, and this is what it is, these are the fecal matter transplants. Again, the next one we'll get in a little deeper. Oh, I don't know. We're getting a little deeper into the poop? Well, maybe. Oh, man. Here we go. Next time around. I love you all. Bye.